So in this class we will see about the orbital perturbations. And what are these what is meant by orbital perturbations means when a satellite is moving in its orbit, there are some external forces which will be acting on the satellite, and these forces will make the satellite to move away from the actual orbit which it has to revolve. Those external forces which are acting on the satellite together, we call it as orbital perturbations. And some of the orbital perturbations we have is Earth's obliqueness. It is the shape of the Earth because the Earth's surface is not completely a sphere and not completely an ellipse. The shape of the Earth we can call it as triaxial ellipsoid, we can call it as, where it is flattened at the poles and bulged at the equator, and there is no uniform gravity towards the entire surface of the Earth. There are some changes in the gravity from the poles to the equator. Due to these changes in gravity, this will act as an external force to the satellite, and this may change the path of the actual satellite route. And another factor which will be affecting the satellites is atmospheric drag. Affects mainly for low Earth orbit satellites because atmospheric drag is not for satellites which are very long from the Earth's surface but which are close to the Earth's surface. It reduces the satellite velocity and altitude and leads to orbital decay and eventually re-entry. And another orbital perturbation is solar radiation pressure because the sun radiates so much of heat energy, and this radiation can also cause change in the path of the satellite. It is a force exerted by sunlight on the satellite surface, can alter the orbit and satellite altitude over time. And another orbital perturbation is gravitational attraction of the sun and moon because there is always a gravitational force even from the sun as well as the moon, and these forces are also acting on the satellite, and these may change the path of the satellite. And lastly, we have another effect which we call it as magnetic and tidal effects. Interaction with Earth's magnetic field and tidal forces, usually smaller but can influence long duration missions.